Okay, good morning student. Today going to the continue of the chemical properties in hydroxy compounds and ethers compound. Okay, so already last class we will study the S1 reaction, SN2 reaction, E1 mechanism, E2 mechanism, States rule, oxidation method, some other chemical properties we will see in the last class. Today going to the balance of the chemical properties and the properties of glycerol and glycol. We will see that. Okay. So first I will go into the chemical properties of glycol. I will take the first one reactions. We will take the ethylene glycol. It is one of the dihatic alcohol. Two hydroxyl group are present in the compound. So it is one of the best examples of dihatic alcohol. First I will take that. I will add the phosphorus triiodide. The phosphorus compound, already you will see the Victor-Meyer test. The phosphorus iodide will add the primary, secondary and tertiary alcohol. It is removed in the hydroxyl group and will substitute to the iodine, bromine or any one of the halogen compound or substitute in the Victor-Meyer test. Okay, the same compound I will take it in this reactions. So I will add the phosphorus triiodide. So it is remove one more hydroxyl group and one iodide compound or substitute this carbon. As well as the same reaction is possible to this hydroxyl group is removed, another one iodine is substitute this position. Okay, why two iodine are samely substitute in the first carbon and second carbon? That means the first carbon is one of the primary alcohol nature. Do you know the primary, secondary, tertiary alcohol? So the first carbon, the nature is a primary alcohol, as well as the second carbon is same the primary nature. Why? Already I will explain the last class. The functional group present at carbon is directly involved in only one carbon atom. So the carbon is primary nature. As well as the functional group present at carbon directly involved in only one carbon atom. So it is as well as primary nature. So the ethylene glycol, two carbon atoms is always primary nature. So the reaction is as well as same nature. Okay. So two iodine group is substitute this carbon. This symbol is this. The square shape is this compound is unstable compound. Why? The iodine molecules is very bulky compound compared to carbon, hydrogen. So the atomic size is very big. So the iodine compound size is very bulky compound. So two iodine groups is very closely packed in the closely involved in the carbon atom. So the steric effect is formed to this compound. So it is the unstable. The symbol is mentioned to the unstable. So it is immediately removed. One more iodine is going out. So I2 is relieved. So this carbon is one iodine is released. Another one carbon is one iodine is released. So you will get the new bond is formed. So you will get it one of the alkene group, that is the ethylene or ethene one in ethylene. Ethylene. Okay. As well as you take the another one reaction, the same nature of ethylene glycol, you will add nitration reaction, nitric acid, the catalyst is the sulfuric acid. I will take, you will take any one reaction, you will add the nitration reaction. Definitely the catalyst is called sulfuric acid, corn sulfuric acid, you will add it. Okay, I will write the nitric acid HONO2, that is the HNO3, HONO2. So the one water molecules HO and H. So H2O, one more water molecules removed, as well as the same reaction in this hydrogen. So you will get it removing two water molecules, 2H2O. So the NO2 group it substitute this oxygen, as well as the same another one NO2 group substitute this position. So you will get it NO2 and NO2. So ethylene dinitrate or dinitroethane or ethylene dinitrate, you will get it. So next one, a very important reactions, dehydration nature of ethylene glycol. So I will take glycol C2H. So I will heat it, just heat it. You will remove it. One more water molecules is going out. So the oxygens already you know the valency of oxygen is 2. So the oxygen is directly involved to the alkyl group. So I will get ethoxide. So ethoxide coming getting from heating of ethylene glycol and water molecules remove it. So suppose we will this reaction one of the reversible reaction. So you will cool it, you will get it the ethylene glycol remaining. Okay. Then another one hydroxyl reaction, dehydration reaction, will take the glycol, you will choose the catalyst sulfuric acid or anhydrous zinc chloride and just heat it. So you will get it. First one is a student, one hydroxyl group and this hydrogen is H. Okay, CH2, I will write it CH2, CH. So this hydroxyl group and one hydrogen is going out. So one water molecule is removing, minus H2O. Okay, so one more atoms are released in the CH2 group as well as the hydrogen is released in the carbon. So you will get the new bond CH2. So remaining balance compound is I will write it CH and OH. Then the tautomerism is possible. Tautomerism is the compound is readding. So this bond is break, this one bond is break, as well as this bond is break. The hydrogen is going to the CH2. So we will getting from CH3. So the carbon is directly involved to the another one bond in carbon. The oxygen directly involved to the another one bond is carbon. So we will get it CHO. So CH3 CHO, that is the alkanol or acetaldehyde. Acetaldehyde. Okay. Next, it is another one important method of dehydration of ethylene glycol. The ethylene glycol is write it straightly OH, CH2, CH2 and then OH. I will take 2 times ethylene glycol. So the 2 water molecules going out. It is one water molecule is going out H2O. It is another one water molecule is going to H2O. So 2 water molecules going out. So minus 2 H2O. Minus 2 H2O. So I will get it. Then the carbon is added to the oxygen. The same carbons will include the oxygen. So you will get O CH2 CH2 O CH2 CH2 O then CH2 CH2. Okay, ethylene dioxide. Okay, it is a very important some reactions of ethylene glycol. Okay, then I will going to the next another trihydroxy alcohol glycerol. So I will take the reactions of glycerol. First one is called nitration. You know trihydric alcohol. Trihydric alcohol means 3 hydroxyl group are present in the organic compound. So the 3 hydroxyl group are present in same carbon or different carbon. I will take this compound glycerol. The 3 hydroxyl group are present in different carbon. The nature of carbon is, it is the primary nature. The first one carbon is primary nature. Second one carbon secondary nature. Third one carbon as well as primary nature. It is not tertiary. That is the primary nature. Functional group present at carbon directly involved 1. So primary. Functional group present at carbon directly involved 2. So secondary. Functional group present at carbon directly involved 1. So primary. So first carbon and the third carbon is same nature. Second carbon is a different nature. Okay. So the nitric acid as well as the same nitric acid is will added. So I write the nitric acid HONO2. So I will take 3 times. So as the same reaction, one H2O molecule is going out. The nitrate group is substitute. The 3 compound add the 3 hydroxyl group. You will get remove the 3 water molecules going out. So you will get first 1, 2, 3 nitrate groups are substituted in the glycerol. So you will get trinitroglycerol or glycerine trinitrate. It is one of the explosive compound. Glycerine, GTN, glycerine trinitrate. It is the explosive compound. Okay. Then dehydration of glycerol compound. Very important reaction. You will get the agrolene. So you will take the potassium bisulfate. It is a dehydrating agent. Potassium bisulfate, sulfuric acid, H2SO4 or phosphorus pentoxide. It is as well as the used to the another one catalyst, another one dehydrating nature catalyst. Okay. So first one the water molecules then going out H2O. Okay. One molecule H2O remaining one water molecule is going out. this compound, this hydrogen, I will write 2H2 H and another one H. Okay, another one hydrogen, 1 and 2 and O. Okay, H2O. So 2 water molecules going plus 2H2O. Remaining balance CH2. So this group is going out. Always this group is going out. So we will get it the new bond, double bond, and one more hydrogen and another one more hydrogen. The carbon oxygen, we will get the new bond. So CHO. So prop to enol or agrolin. It is very important reactions. Okay, then one oxidation nature of oxidation nature of glycerol. Oxidation nature of glycerol. Okay, the oxidation nature of glycerol, the carbon nature is 2 different types of carbons, primary nature carbon and secondary nature carbon. So you will add some oxidation carbon, nitric acid, potassium hydroxide, phosphorus pentoxide, Fendon reagents. You will take any one of the oxidation reaction, potassium dichromate, potassium permanganate. So you will get the different product. First, the oxidation nature is primary alcohol is going out, oxidized. Another one, secondary alcohol is oxidized. As well as the same time, secondary alcohol first oxidized, primary alcohol is second wise oxidized. I will explain this reaction. So you know, this is primary nature, this is secondary nature as well as primary nature. First I will take this position. The primary alcohol is first oxidized. Primary alcohol oxidized, you will get first aldehyde, then acid. So in the carbon is primary nature, so it is going to the aldehyde nature, then it is coming from acid nature. This is another one primary alcohol. First to go into the aldehyde, then acid. So you will get it COH, CHOH, COH. Okay. As well at the same time, first we will oxidize to the secondary alcohol. So secondary alcohols oxidize, you will get it the ketone compound. The primary alcohols resting. Remaining the primary alcohol oxidize, it is going to first one aldehyde, then acid. As well as the same this compound, this carbon aldehyde, then acid. So you will diketonic compound. So remaining oxides we will go into oxalic acid. We will go into oxalic acid. The CO2 compound is going out as well as the CHO is going out. You will get it oxalic acid is finally compound. Okay. Okay, students. Next going to the acidity nature of alcohol. So once again repeat the chapter. Alcohols preparations. You will see that physical properties, chemical properties. Then chemical properties we will see primary alcohol, monohetic alcohol, dihetic alcohol and trihetic alcohol. Monohetic alcohol, for example, ethanol properties we will see that, and dihetic alcohol, ethylene glycol, and trihetic alcohol, glycerol, you will see that. Then going to the acidity natures of alcohol. You know the Bronsted theory, Bronsted theory, it is explained to the 11th, already you will know. So which one of the compound is produce the proton, that is called acid. Which one of the compound is produce the protons, that is called acid. So this nature is applicable to the all compounds. So you know the water is the mild acidic nature. So the water Ka value is explained to the acidic nature's value. So the Ka value of water is 1.8 into 10 to the power of minus 16. As well as the alcohol, you will take all alcohol, the Ka value is the 10 power minus 18 to 10 power minus 16. So alcohol, already you know, water is one of the neutral compound, but water is easily produced to the hydrogen or proton. So it is partially acidic nature is possible. As well as the alcohol is always ROH is donated to the proton. It is the possible to the acid nature, but compared to the water is more acidic compared to alcohol. Why? The Ka value is water high compared to the alcohol, but the very first alcohol, methyl alcohol, CH3OH. CH3OH is quickly remove the proton, so it is more strong to the water. So the water is strong acid compared to other alcohol, but it is the weak acid compared to the methanol. Okay, so we will take any one of the alcohol compound and metal, for example sodium and aluminum. So sodium or aluminum or some other metal compounds reacted to the alcohol, it is removed to the proton and sodium is submit, we will get sodium methoxide and hydrogen. So the alcohol compounds liberate the proton in metals, so it is the acid nature, it is present in acid nature. So next, very important one, comparison of acidity of primary, secondary, tertiary alcohol. So the acidic strength, which one is high, which one is low? You know, I will take the first one, I take the ethyl alcohol, isopropyl alcohol, second one isopropyl alcohol and tertiary butyl alcohol. It is the primary alcohol, secondary alcohol and tertiary alcohol, which is more strong. So the acidity nature of high is primary alcohol, then secondary alcohol, then tertiary alcohol. Why primary alcohol is more acidity compared to other? The primary alcohol is more acidity, it is the OH bond is the polar nature bond. OH bond is the polar nature bond. It is mostly affected the electrons or remove the electrons. You know, the oxygen already present in two lone pair electrons. In alkyl group, electron withdrawing group, electron releasing group. So electron is released, so going to come to another alkyl group, it is electron release, so it is always come this place, the oxygen is electron rich, so it is easily removed to the hydrogen, it is easily removed to the hydrogen. So primary is alcohol is more acidic. Compared to this, the two alkyl group accepted to the electron is positive nature, accepted to the electron, the polar nature is decreased, the electron and the proton removing very slow. Here three alkyl group are present in this compound, the hydrogen is removing very difficult, but it is possible, so the acidic nature is very low compared to primary and then secondary. Okay, how is possible to the hydrogen is the more acidic compared to alcohol? This one very simple reaction. We will take the ethanol CH3CH2OH and water molecules. So this carbon is donate the this oxygen is donate the electron in hydrogen, so we will get one of the oxonium ion. So the this position electron is accepted to this oxygen, we will get negative ions. So you will get the positive compound and the negative ions, positive ions and the negative ion. Alcohols is accept the hydrogen, water is donate the hydrogen, so it is easily removed to the proton, so it is the better acid compared to alcohol. So water is best acidic compared to all alcohol compounds, but it is less acidic compared to methanol. That's all. Okay, we will repeat once again. Comparison of acidic acid, primary, secondary and tertiary alcohol. Primary alcohol is more acidic compared to secondary, compared to tertiary. Okay, then we will study. Bye.